We're going to review the Pythagorean Theorem. Now you would have started with the Pythagorean Theorem in grade 7 or grade 8, and you would have definitely reviewed it in grade 9 as well. And so there's a couple things we need to make sure that we know. The Pythagorean Theorem can only ever be used with right-angled triangles. So in that first blank we can put the phrase right-angled. From there, we know that the longest side in your right angled triangle is always called the hypotenuse. So in the second blank here, we're going to put the word hypotenuse. There we go. And that hypotenuse will always be the side that is across from your 90-degree angle. Let's try that again. Across from your 90-degree angle. Okay, so it's always opposite to that 90-degree angle. So we'll talk about that more. It's really important that you make sure you know what that means. Now the Pythagorean states that in a right angle triangle, the square of the length of the hypotenuse, so if you take the length of the hypotenuse to the exponent of 2, that will be equal to the sum means to add things together, so that will equal the sum, so we're going to add the squares of the lengths, so we're going to take the lengths to the exponent of 2 of the other two sides. So more formula-wise, we're taking the hypotenuse to the exponent of 2, and that will equal the sum of the squares of the lengths. So square just means an exponent of 2, the lengths of the other two sides. So we're taking side 1 to the exponent of 2 and adding it to side 2 to the exponent of 2. Or for short, we're really doing h squared, hypotenuse squared, equals a squared plus b squared. And your a and your b are your two short sides. So the a and the b are the shorter sides. And your h is always the hypotenuse. The longest side goes by itself. Okay, so that's the hypotenuse there. Hypotenuse. So it takes the two shorter sides put together to make up the square of the hypotenuse. All right, so use the Pythagorean theorem to determine the length of the unknown side. So in this first example, part A, I don't know this side here, and that side is directly across from your 90-degree angle. So this side here is actually our hypotenuse. That means the 5 and the 12 are our shorter sides, and we could make that A and that one B. And then if we use our formula, the hypotenuse squared is equal to A squared plus B squared. I can sub in what I know. I don't know the hypotenuse. I've labeled it X, so we'll make that X squared equals, the A is just 5 centimeters, and the B is the 12 centimeters. Now it doesn't really matter which one I called A and B. The B could be the 5 centimeters and the A could be the 12 centimeters. In the end, when you're adding them, it doesn't really matter. It's not going to make a difference. So if we square 5, we get 25. If we square 12, we get 144. And then if we add those together, you're going to get 169. Now that's what the hypotenuse squared is, but we don't want the square of the hypotenuse. We want actually just the hypotenuse. So we have to undo the exponent of 2. And to undo an exponent of 2, we undo that by taking the square root. And the square root of 169 is 13. So we know that the hypotenuse is 13 centimeters. Okay, now you have this marked on as your 90-degree angle in your picture or diagram. Your job is to find the length of the unknown side, which is this side here. So put the video on pause, turn the screen over, try the question, see what you can do on your own, and then go through the video afterwards, push play again, and you can check your work. So put the video on pause now and turn your screen over. Okay, if we're identifying information here, we know the side across from the 90 degrees, that's your hypotenuse. Your shorter sides will be your A and your B, and it doesn't matter which one's which. And then we sub in what we know. The hypotenuse we don't know, so it's just an X. The A could be the 16.8 to the exponent of 2, and the B is the 7.1 to the exponent of 2. Okay, so when I calculated those squares and then I added them together, I got 332.65. And then to undo that exponent of 2, I'm going to square root both sides. So square root that to undo the exponent 2, but I also have to do it to the other side. And when I do that, I get approximately equal to 18.2. I'm just going to one decimal place because the sides that I was given in the question, they also only went to one decimal place. So I'm just rounding that to one decimal place. So our hypotenuse is about 18.2 centimeters. Try the next two examples that follow this. So again, you can put the video on pause, turn your screen over, try the question, and then you can check your work. Okay, so we need to identify which side is our hypotenuse. Here's your right angle. Across from it will be your hypotenuse. So this is hypotenuse here. For part D, across from that right angle, this side is your hypotenuse. So in both of these examples, you were given the hypotenuse, and what you need to figure out is one of the short sides. So I can call this one, it doesn't matter which one's A and which one's B. I'm going to call this one down here A and this one here B. I'm going to call this one A, maybe A, there we go, and this one B. And I'm going to fill things in, and then you can check your work. Okay, so for part C here, we were given the hypotenuse, so you'll notice that I substituted that right in on the on the left-hand side of the equal sign, because that's where the hypotenuse goes. And then I left my A as an A because I don't know that value, and my B I substituted in the 15.7. And then I actually calculated those squares. So I got these two numbers. Now I need to get A squared by itself, so to undo the 246 from both sides, what I'm actually going to do is take away 246.49 from both sides. So I'm going to take away 246. I'm just sliding this underneath because I don't have room to write it above or below, beside. So I'm going to take that away from the 497.29. And when I do, I get 250.8. 250.8. And that's going to be equal to A squared. And then to get A by itself, we square root both sides, hit the square root button on the calculator, and I got A being approximately equal to 15.8. And again, I'm rounding to one decimal place because the question had their numbers to one decimal place. Try part D if you have not done so already, and I'll put up a solution. Okay, and if you follow through with part B, the hypotenuse was the 5.8, and the short side that I knew was 4.1, so I squared them, and then I subtracted the 4.1 squared, which is 16.81 from both sides. And when I subtracted it, I was left with 16.83, and then square root both sides, and I got a 4.1 meters as that missing side. So it's almost an isosceles triangle there. If I went to more decimal places, I'm not quite isosceles, but it's pretty darn close. All right, here we have a word problem. A 22-foot ladder is leaning up against the wall. So you've got a wall. Let me actually use the pen tool. There we go. Sorry about that. We have the wall and we have the ground. Okay, so here's my building, making a right angle hopefully with the ground. The ladder itself is propped up against the wall. It's leaning up against the wall. So let me draw the ladder in here. It's just a side view of the ladder up against the house or the wall. The base of the ladder, base means bottom. The bottom of the ladder is 5 feet from the bottom of the wall. So this distance here, just right here to here, that's 5 feet. And we know the ladder itself was 22 feet. So I'm putting the 22 feet. That's really my hypotenuse. It's across from my 90-degree angle. So I'm going to label that with hypotenuse right away so I don't forget. And we want to know how high up the wall it's going to reach. So I'm going to make that a short side. I'll just call that side A. And this 5 feet is like my side B. So we need to solve for side A. The hardest part with these questions is just reading the question and then organizing the information. But even doing a diagram is a real great start, and I can give you part marks for creating a decent diagram. Even if you can't solve a problem, starting to organize the information is part of your problem solving process. So try that out, get your answer, and then you can check it. Okay, so if you check your work here, the 22 goes in for hypotenuse, the 5 is one of the short sides. Square those numbers, subtract 25 to get the a squared by itself, then square root, and you get about 21.4 meters, so that the ladder will reach about 21.4 meters up the wall.